Hello everyone. In this tutorial, you are going to understand linear regression model slope and residuals. Let's have a look at this diagram. You remember this example when we have the experience and salary for the employees. And we said that this is the x-axis where the year of experience is located, and this is the y-axis which is the monthly salary. And the data is scattered here based on the years of experience and monthly salary. So for example, this point located on 2, that's mean 2 years experience and 2,500 salary, which is the first one. And the second one here, 2 years experience and 3,000 salary, which is the second one, and so on. After that, we draw a line, we call it the slope line of the regression that fit these data. But you see here that this line cannot fit all the data here, because the regression model trying to fit the most of the possible data. It cannot fit all the data unless the data is exactly in this trend, exactly located in the same line where the fitting line of the regression model. So in this case, we will have a difference between the actual value, which is here. These are the actual values. Any value is not located on this slope line is an actual value. These are the actual values. And the points located on the slope line are the predicted values. So that's why we call any value on the slope line, we call it y hat. And you remember before in the previous tutorials when we said that y hat is the value which is predicted by the regression model, and the actual value is y. So this is y hat and this is y. And you see that there is a difference, there is a gap between these two values, and we call this difference residuals. So this is the first residual. For example, the first employee is receiving 2,500 and he has or she has 2 years experience. So that's why this point is located here. But the regression model says something different. Say the employee with the 2 years experience will have something about 3,000, which is one of them here, but that's what is predicted. Every 2 years experience, 3,000 salary. But this is not always correct. We have one of them 3,000, but the other one is 2,500. And the same thing. For example, here you see that this point here, for example, predicted 3 years and the salary is about something 3,500, but actually it is 4,000. So that's why we find a gap between the actual value and the predicted value. So the question that we need to ask here, how we are going to figure out how to draw the slope line? Why the slope line is something like that or like that? There should be a way to tell us what is the right slope line that fit most of the data. And the answer for that is minimum sum y minus y hat squared. So the best fitting model or the best fitting line or slope is the one that achieve minimum sum y minus y hat squared. So if we go back here, we have this residual, which is y minus y hat. So we have this value. So we take this value and square it. And we take this value and square it. And we take this value and square it, and so on until we take all these values. And the slope line is the one that achieve the minimum sum of y minus y hat squared. So after we take each y minus y hat squared, we add up all these values of y minus y hat, and finally we'll get a sum. Then we draw another line, and also we'll take the y minus y hat squared. Then again and again, let's say we have thousands of these lines. I just give an example of 2 plus this one, that assuming this is the best fitting line. And only one of these, all these slope lines will achieve minimum sum of y minus y hat squared, and this is the best fitting line. And of course, we are not going to draw thousands of these lines and try. Everything is done by the computer. The algorithm here in Excel or in Gretel or in R are doing that for us behind the scene and finally give us the best fitting line. And of course, the slope starts with the minimum value here, which is the minimum salary. And this line here is not accurate 100% because it's just draw randomly. It's supposed to start somewhere here because the minimum here is 2,500 in this example. So based on the data that we have in this table, 2,500 is the minimum value. So the slope line should start from here and go straight that way. And we call this method to determine the best fitting line, we call it ordinary least squares, or OLS, because we are trying to find the least squares. And this is not the only way to figure out or to determine the slope line, but is one of the most reliable methods and the easiest ones to understand and used in applications to figure out the best fitting line.